All right, so the next program in chapter 5 is present value. Okay, so suppose you want to deposit a certain amount of money into a savings account and then leave it alone to draw interest for the next 10 years. At the end of 10 years, you would like to have $10,000 in the account. How much do you need to deposit today to make that happen? You can use the following formula, which is known as the present value formula, to find out. So P is equal to F, all divided by 1 plus R raised to the power N. Now, 1 plus R is raised to the power N. I couldn't, format it well, so that's how it was. Actually, the question is here. I can show you here. This is how the formula looks like. Okay, 1 plus R raised to the power N. Okay, so the terms in the formula are as follows. P is the present value, or the amounts that you need to deposit today. F is the future value that you want in the account. In this case, F is 10,000. Now, 10,000 is how much we want to have at the end of, let's say, a certain number of years. R is the annual interest rate. N is the number of years that you plan to let the money sit in the account. Now, write a method named present value that performs this calculation. The method should accept the future value, annual interest rate, and the number of years as argument. It should return the present value, which is the amount that you need to deposit today. Demonstrate the method in a program that lets the user experiment with different values for the formula's terms. Okay, so this this question wants us to create a program that's going to allow us. So basically, we ultimately are creating a method, but the program is generally going to allow us to be able to tell how much money we are going to have at the end of, let's say, a certain number of years by depositing money today. For example, I want to know how much I'm going to earn in 10 years. No, actually, I'm explaining it differently. I want to know how much I should deposit into the bank account today if I'm to make, let's say, $10,000 in 10 years. Or I want to know how much I should deposit into the bank account today if I'm to make, let's say, $100,000 in 18 years. Right. So actually, we are trying to figure out how much money we should deposit into a bank account today based on the interest that's going to build on top of it. How much should I deposit today in order to get, let's say, $100,000 in 5 years? So this program is going to tell us how much we are depositing today, right? And how much we're depositing today is going to be the present value. This is the present value we need to deposit, the amount you need to deposit today. F is going to be the future value that you want, like how much do you want in the future? And N is the number of years that you plan to let the money sit into the accounts, let's say in 10 years or in 15 years. R is the interest rate, but that's going to be the interest rate of the bank or something. All right, so let's go ahead and start. I'll go ahead and I'll create the main method. And then I'll call this present value. And then I'll create the... Actually, this was the class. Okay, this is the class. So public class present value. And just 1 second here, please. Okay, so this is the class, and I'm going to create the main method now. Oops. Okay. So now we have the class, we have the main method. Let's see. Now the program wants us to write a method named present value that performs this calculation, and it's giving us all the details about the method. Before I start creating the method, in all the chapter 5 videos I mentioned that others like to create or define their methods right below the main method, and that's going to work. That's going to be fun. Once you define it in main method, once you define it below the main method, you can call the method in the main method. You can call it in the main. It doesn't matter if it's below the main method, as long as you define it. It's available. But I'm going to define mine above the main method. It's still going to work. It's the same thing. I'm just defining mine above it. Sometimes it's logical to me that way, but I mix it around. Sometimes I define it above the main method. Sometimes I define it below the main method. But for this one, I'm going to define it above the main method. So the program wants us to write a method named present value. So let's go ahead and do that. I'm going to go ahead and create a public static method. Public because this method is going to be available to code outside this class, and static because this method belongs to this class. It's going to belong to this class. Okay, so now I need to specify the return type of the method. Let's read and see if the question tells us. So the method should accept the future value and annual interest in the number of years as argument. It should return, okay, now we see over here it's saying it should return the present value. Now the present value is basically how much money we should deposit into the account. Now that money can be a double. It can be a decimal. It can be, let's say, $1,000.50. It can be $2.80. So in that case, it would make sense to define the return type of this method as a double. So I'm going to do that. I'm going to define the return type as a double. And then now we have to type the name of the method. Over here it says write the method named present value. So we know the name of the method is present value. So present value is going to be the name of the method. Now I'm going to put in my parentheses for any parameters that I'm going to define. Now let's see if the method is going to accept an argument. It says write a method named present value that performs this calculation. The method should accept the future value. So we know the method is going to accept some argument. So we need to go ahead and define some parameters, right? So the method should accept the future value. So we know the first thing it's accepting is the future value. So let's define a parameter for the future value. So the future value is also going to be an amount, like let's say a monetary value. It can be, let's say, $10,000, or it can be $5,000.50 or $5,000.25. Okay, or 4950.20. You know, it can also be a double. So I'm going to define that parameter as a double. So double, and I'm going to call it future value. Oops, my typing is not good. So double future value. Now the method has more parameters over here. It says the method should accept the future value, the annual interest rate. Now annual interest rate also, I mean, it depends on how you want to accept the annual interest rate. If you want to accept it as just a regular number, you can. If you want to accept it as a double, you can. But let's what we should do is we should make this program flexible, because if we ask the user to, let's say, type in the annual interest rate, right, the user could end up typing 5, which means 5%. So let's still go ahead and define it as a double, right? But whatever the user types is going to be divided by 100. We are not expecting the user to type in or do the math and type in 0.0 for 5% or 0.5 for 50%. We don't want that. We want the program, the user to just type the regular number they know. So if it's 5%, they're going to type 5. If it's 2%, they're going to type 2. And then in the method itself, we're going to do the calculation divided by 100 to get the real decimal value of it, right? Okay, so still it's going to be a double because the user can say 5.5%, okay, or 6.5%, right? We're still going to divide by 100 to find the exact decimal interest value, right? So I'm going to also define the interest rate as a double. I'll call it annual interest rate. Now the method has more parameters over here. Now it says and the number of years as argument. So the future value, the annual interest rate, and the number of years as argument. Number of years, we know it's just a number of years, right? We know it's going to be an integer because we are dealing with a number of years. It's either 5 years or 6 years or 8 years. If you want, you can make it a double. If you want, you can make it a double and then allow the user to type in, let's say, the exact number of years. Let's say 1.5, okay, or to mean 1.5. You can do that. Actually, let's do that just to make the program flexible. So I'm going to go ahead and define that also as a double. And I'll call it number of years because the user can type in 1.5 to mean 1.5 years. So number of years as argument over here. So number of years here. Also defined as a double. Now we have we will have all the parameters if the user provides them. Now we have to go ahead and define or create the method, creates the engine of the method pretty much. Alright, so we've done that. Now it says Demonstrate the method in a program that lets. Okay, so now we know we have the formula here. We have the formula here, and we know we'll have all the parameters here. So now let's go ahead and, well, first of all, I wanted to change the annual interest rate to like a real decimal value. If the user typed in 5, I wanted to change that to a real 5%, meaning divide 5 by 100 to get 0.05, right? So what I should do is, because if the user types in 5%, you don't want to use 5% like that. You want to divide by 100 to get 0.05. So the first thing I'm going to do is I'm going to define a variable in here. Let's see. Actually, yeah, I'll define a variable. Actually, it's going to be the same variable here, annual interest rate. I'm going to basically divide by 100 and then store it back in annual interest rate. So what I'm going to do is I'm going to say annual interest rate is going to be equal to what's already stored in annual interest rate divided by 100. Okay, annual interest rate is going to be equal to what's already stored in annual interest rate divided by 100, and it's going to store the result back in annual interest rate. So the user types in 5 annual interest rate over here. It's going to say 5 divided by 100 and store 0.05 back in annual interest rate. So now we're changing the value of annual interest rate to now a real decimal value. Sorry about that. Okay. So now we'll have the annual interest rate. So now we have the formula here to calculate the present value. So I'm going to define a variable called present value. So to hold the present value. So double present value. Present value because present value is going to be, we mentioned over here that this method is going to return a double, and it's going to basically return a present value. So present value is going to be double because it's going to be an amount. It's going to be a monetary value. So double present value, and then over here we're going to say present value is going to be equal to, now this is the formula we're trying to create here. So P is equal to F, which is the future value, okay, the future value, divided by, in parentheses over here, 1 plus R, and R we know is the annual interest rate. It says over here, R is the annual interest rate. So future value, all in parentheses, 1 plus the annual interest rate, okay, and we know all of that is raised to the power n. Now let me show you over here in the question. This is the formula over here, 1 plus R all raised to the power n. Okay, so this is raised to the power n. Now we can use a math class to do that. Okay, you can use a math class to do that. In the math class, there's a method called POW, or POW, which basically takes two arguments. It takes the two arguments, the first argument and the second argument, and basically raises the first argument to the power of the second argument. So let me show you what I mean. So I'm going to call it method of POW, and it's around, basically passing two arguments. So this is going to be one whole, let's see. So it's 1 plus R all to the power n. Okay, so this is the power n. All right. So this is the first argument I'm given to it. This is the first argument I'm given to the method of POW method, right? And then the second argument is going to be n, which is going to be a number of years. N is the number of years. Okay, so number of years this way. And what this method does is, this method of POW takes in two arguments. This is the first argument, and this is the second argument. It's going to raise this first argument to the power number of years. If I had, let's say, 2 here and I had, let's say, 4 here, what this method of POW is doing is it's going to be basically 2 raised to the power 4. It's raising the first argument to the power 4. So 2 raised to the power 4. I'm going to undo it back to what I had. So I'm raising 1 plus annual interest rate all the way to the power n. Okay, so 1 plus R to the power n, or 1 plus annual interest rate to the power number of years. Yes, and S. Okay, and then I need my semicolon here. So basically we have calculated this, and we're going to store the result in present value. And now once we have the present value, all we have to do is now go ahead and return it. Let's see. Yep, return it. Return the present value. Like this. So now we've defined the method. We know the method is going to return present value. Now the program over here says, demonstrate the method in a program that lets the user experiment with different values for the formulas for the formulas terms. I mean, we can just go ahead and call the method and then pass in some values and or we can make it interactive and allow the user to go back and forth and enter values. But for just for simplicity, let's just go ahead and test it by putting in values ourselves. So in main, I'm going to go ahead and call the method. I'll call the method. Actually call system.out.println, just so we can print out what is being returned by the method. So I'm going to call the method in the println function. Present value. So I want to know how much I want to know the present value that I should deposit into the bank account if I wanted to make, let's say, $10,000 in 10 years, right? So present value needs a couple of arguments. So future value, I want to make $10,000. So 10,000, 1, 2, 3. Okay, so 10,000, and annual interest rate, let's say, is 5%. And now the bank decides this, but I'm just testing this. A number of years, I want to keep it there for. Okay, so in 5 years, so basically all I'm asking is, in 5 years, how much money do I have to deposit in the bank today if I wanted to make $10,000 in 5 years at an annual interest rate of 5%? And then I can even go ahead and format it, but let's just go ahead and compile this and run it and see what happens. So I'm in chapter 5. I'm going to create a folder for present value, and then I'll save this as present value. All right, so I have a couple of errors. I forgot to terminate this method, so I'll go ahead and terminate it and compile this. Some more errors. Let's see. Math cannot be applied to null type double. Annual interest rate. Well, first of all, let's fix the other ones. And okay, so I over here typed in 3 n's for annual interest rate. I define it as annual interest rate with double 2 n's. So I'm going to delete one, and that fixed it. Sometimes it's not really there. Sometimes there's other problems. All right, so let's run this and see what it prints. All right, so now I would have to. I don't know if it makes sense because I don't know all this math stuff. But according to this question, it means I have to deposit $7,835 if I wanted to make $10,000 in 5 years, with interest built on top of that at an annual interest rate of 5%. Now let's see if it makes sense. If I wanted to be, let's say, a millionaire, right? Let's say I wanted to get $1 million. Let's see. So 1, 2, 3, 1. So $1 million in, let's say, 20 years at an interest rate of 5. How much do I have to put in the bank now in 20 years if I wanted to make $1 million? Compile this and then run it. I'd have to put $376,889 in order to get $1 million. Okay, 5%. What about 15%? Now that's a lot, but let's just try it out and see. I'd have to put 61,100 to be $1 million in 20 years. I don't know about the numbers, but hey, according to the question, we've done it right, so it should be correct. The next thing we have to do is just format this value so it looks good. Now I can go ahead and use a printf version, so print formatted, and then specify basically a format, right? I'm going to specify a format. So the printf format takes basically how you want it formatted and what you're formatting. So this is the first argument. This is how I want it formatted. It's going to go here. It's the first argument. The second argument is basically what I want formatted. I want the return value of the present value function, or the present value method. I want it formatted the way I'm going to specify it here as a first argument. So I know that it's going to be a double, right? I know it's going to be a double, meaning a floating point number. Okay, a double, it's a floating point number. So because of that, I'm going to basically type in percentage F because I want it formatted as a floating point number. This percentage F is basically saying that I want to format this as a floating point number. Now I want it also rounded to 2 decimal places, right? So I need to specify the precision. Now I'm going to put in between the percentage and the F, I'm going to put 0.2, which means I want it formatted to 2 decimal places. So 0.2 means 2 decimal places. If I wanted it formatted to 3 decimal places, I'd say 0.3 over here. Now I want it formatted to 2 decimal places, I'll say 0.2. And I'm going to put commas where necessary, meaning put commas in the value where necessary. If I had $1 million displayed as 1,000,000, automatically put commas where necessary, so that it looks like a real monetary value. So I'm going to put a comma before the precision. So the comma comes first before the precision, all in between the percentage and the F. And then because also I wanted a $sign in front of it, I'm going to put a $sign even before the percentage, and everything, before everything. And then this is what I am formatting. So I'm going to compile this, run it, and now when I run it, now it looks like a real dollar amount. We have a comma where necessary, 61,100.28 cents, a $sign in front of it, and it's rounded to 2 decimal places. We can see here. Okay. So if the formula is correct, then the value should be correct. Okay, so now we're done. Okay, so if you have any questions, please comment down below and I'll do everything to respond to them. Thank you very much for watching. Take care of yourselves, and I'll see you next time with the next program. All right, bye bye.